I think it's visible now. So, okay. So my job for today is to walk you through some of the developments that we have been busy with for the last year, I think. I wanted to show you what we've developed, how it looks like, maybe run through some live sessions with you today for the new tools that we built, explain you why they're useful. And then last thing, I will try to I will try to walk you through what's coming. Yeah. So the first half of my 40 minutes presentation, I'm going to be talking about the new software tool that we've built. It's called ModelChoice. It's a tool for decision making, a tool for building decision trees, and I'm going to show you what it's for, how it looks like, how to operate it, what types of benefits you can get from it. Then the next 15 minutes, I'm going to show you ModelRisk and the new tools that we've built with ModelRisk, the 4 tools that we've recently added. And then finally, in the last 5 minutes, I'm going to explain you what we are building actually. All right, so let's start. So ModelChoice. ModelChoice, yeah, we actually called it Model Tree to start with, but that name was taken by some other software. So our software became ModelChoice. We develop tools for risk analysis, which you all know, this ModelRisk and Timour and Pelican. And with ModelRisk, you can create models which include your uncertainties, which include your risks, which help you go from static models to stochastic ones. What ModelRisk is missing is an easy way to model decisions. Right? You can model it, the tools are there, but it's not easy. It's not the ModelRisk is not focused on analyzing the specific decisions that decision makers need to make. That's why we have this new tool called ModelChoice. It closes the gap and it allows you to easily model the decisions, easily evaluate those decisions, see how well they are established, and it also provides you very easy, user-friendly interface to actually create reports out of your analysis. I'm going to walk you through a simple example of some company called Terra Nova Energy, who holds a license on a drilling prospect called Kestrel. There are 3 ways of that are in front of the decision makers in the boardroom. So we have a license to drill. We can decide to walk away, so not drill. We can decide to drill right now. And we can decide to make a survey first. So whether we should drill or not, because drilling is investment, of course, no one wants to lose the money. So the walk away decision, right? It's just just not invest basically, and the outcome is 0, right? We have the license, but we're not losing anything. We're not getting anything, so 0. So drill now decision. If we decide to just flip the coin and make the investment, the estimates are that in 30% of chances, we're going to be hitting the gold, right? It's going to be commercial. We will find the thing that we've been drilling for, and it's going to bring us 200 million in cash. But the drilling decision itself, it requires drilling activities, and that will cost 60 million. In the rest 70% of chances, we're gonna drill a hole, spend 60 million, but we get nothing, right? If you multiply all these things together, we get to an expected value of 0. So it's basically flipping a coin. Either we lose 60 million or we win 140 million, right? 200 minus 60. But there is the third option, right? The third option says, 6 million, with the 6 million survey, we can be a little bit more sure whether there is, or maybe a lot more sure whether there is a high chance of finding the gold or not, right? And for CFO is asking a question, it's a coin flip, either yes or no. Why should we pay the 6 million? What's the expected value? And that's where ModelChoice comes into play, allows you to model actually that decision. So we are here at the beginning with the decision point here, with the decision options to drill now, to walk away, and then to invest into a survey. The software allows you to build all these nodes. The walk-away decision is the simplest one. So you do nothing, you lose nothing. Where you drill now, you lose 60 million right at the beginning. And then with a 30% chance, you win 200. With a 70% chance, you win 0. And then the expected value calculated here is $0 of EV. The third one is a bit more complex. So here you're investing the money. So 6 million you're investing in the survey, and you're gonna be expecting, two outcomes: a favorable one and unfavorable one. So depending on what the survey comes back with. And with the favorable decision, if you drill, you invest the 60 million, and then the chances are higher. So if the signals are positive, the chances are higher. And there is now a 60% chance of a win, and then the 40% chance of a loss. And then if it's unfavorable, you can still drill, right? You can still invest 60 million, but then there's only a 10% chance of us winning, and then 90% chance. So the test is not perfect, but it gives you a way to actually know a little bit more information about what the investment is all about. So what the software does, it automatically calculates the optimal path based on all of the data that you put in. So you can see that there's colored lines here, or the bold lines showing you the optimal path. So the best decision you would need to make is to actually do the survey. And then if it's favorable, you drill. If it's not favorable, then you walk away, so you don't drill. So these are your decision paths that are calculated for you. So again, back to the boardroom. Both options you can see are worth nothing. Walk away, drill now. But then how much? So the CFO asked, you pay 6 million to analyze the break-even bet. And then what's the survey is really worth? It's really worth the 25 million bought for 6 million. So you pay 6 million in survey, but you're getting 25 million as an, expected monetary value, EFV. Okay, so that's the value add that the analysis is bringing you, all calculated. Then, okay, so that is in very few words what the software does as an input. Like, it allows you to build the decision trees, and the decision trees can be actually very, very large, right? So with many nodes and interactions between the nodes. There are tools out there that do the same thing, with the precision tree and all the other tools, Excel free tools. But we've Our focus in building this specific tool is to allow the users to build it easily with more user-friendly interfaces, but also do a lot more analytically with the data that you input. So one of the things is the decision brief, which is just a one click of a button, and it gives you all of the information that you need to be able to present the results to people who don't really want to get very deep into your decision tree. So the board will not read a decision tree which is very large. It's for analysts. The board needs to get a report which you can get with just a click of a button. Well, you can do sensitivity analysis. You can see that how the input data is sensitive, or the changes in the input data are sensitive to your outcome, to the decision that it's advising you to take. Then another analysis that I would like to highlight is the force to outcome. So imagine that someone asks, what would it take for us to have this specific outcome? So what needs to happen, right? And then the software will calculate you the exact conditions, will give you the multiple scenarios on what information, what extra information we need to take or to acquire in order for us to be quite certain that the decision that will lead to the specific outcome. Okay. Yeah. So yeah, and then of course you can integrate it with the ModelRisk and add uncertainty distributions to your input variables. So enough talking. I'm gonna be showing you this example live. Just a second. Oops. Yeah. So model tree here, sitting the same tree that I showed you on the slide is sitting here. So this is the model tree ribbon. You can render it. It allows for an easy interface of building the different tree nodes. So you can insert the nodes, you can copy the whole tree, you can paste it elsewhere. Then you can do sensitivity analysis. So you select the variables that you want to stress. You click OK, and then you get the sensitivity analysis. The tornado plots showing you the biggest influences for your decision analysis, etc. The decision brief, again, so decision brief. So let me just quickly load that as well, show you how it looks like. Okay, there it is. So decision brief, it gives you the key numbers in one sheet, which can be printable, converted to a PDF or something. Shows the expected value, the decision, the key drivers behind the decision. So the uncertainty, the sensitivity analysis, the worst and the best cases, the nearest threats. So the threats are things that need to change in order for the decision to also change. So what needs to change in order for the decision to change, right? And then at the end, it also gives you the just pure text description of the key points described in the paragraph, that what the decision is, why the decision is like that, and etc. So pretty useful as a one-page report out of your model. Okay, let me close that. Yeah, and then there are things like, for example, break the decision. So what needs to happen in order for the decision to actually flip? So what is it? And it currently says that it's critical, so not a lot needs to happen. yeah, so these are the things, these are the parameters, they need to change by a certain threshold in order for the decision to flip to another optimal decision, right? And then maybe that gives you food for thought in your decision making. Another useful feature that we introduced with this tool is first of all, there are multiple example models. So you can see example models for each industry, for the application. And there's I'm going to load this one. It's a thing that we introduced into model 3 called MCDA, multi-criteria decision analysis. This is where you care not only about the financial outcomes, but also you care about the specific criteria of success, right? And those criteria of success need to be described here. You need to assign weights to those criteria. And then at each end node, at each outcome, you would define what would be the financial impact and what would be the impact in those other dimensions, right? So maybe you can think of many examples where it's not only financially, and it's not important to only trace financial outcomes, but you also, if you care about, say, sustainability or quality or health and safety or whatever, you can put those in as well, and the software will optimize your decision process, taking into account all those different criteria. So that is what we thought would be helpful in the decision making. And of course, the software is integrated with ModelRisk. So these are input parameters that are feeding into the decision tree. So you can actually go to ModelRisk. You can say that they are probability distributions. Then you run Monte Carlo simulation on this tree. The tree will recalculate at each Monte Carlo sample, and you will be able to find, the optimal strategy under the assumption that, some of the key inputs are uncertain, right? So you will be able to calculate the chances of achieving the target, and you will see what is the probability or what's the frequency of a specific decision being made during the simulation. Very helpful indeed. Okay, so that's ModelChoice. It's available already on our website. We just go to www.vosesoftware.com, Risk in Excel, ModelChoice. You register, you download the trial version. It's going to run for 15 days. You can play with it and see if that helps you. Okay, good. So let's move on. I'm going to close this one. Okay, and this one. I'm going to go back to the slides. ModelRisk. So ModelRisk, 4 features I want to highlight. The first feature I want to highlight is called Highlight. Highlight is a feature that is adding to the ease of use of modeling the risks. So you imagine you have a big model you developed or someone developed, and you need to go into it and you need to analyze it, see what it does and where the uncertain distributions are and where the outputs are, etc. So there are a number of ways of achieving that, but we thought that it would be nice to just have one little button that you click and then it highlights things for you. And that's exactly what we've done. So let me show you how it's done. So highlight NPV. So NPV model, and this is not a very big model, but still. And And in ModelRisk, we have this new button called Highlight. You click it, and you can see immediately everything is highlighted according to the rules that you defined here. So inputs are in green, outputs in red, some drivers in yellow, and then there are others in blue, but you just click, unclick, highlights, unhighlights. So very easy, but also very useful, we think. Okay, the next one. Okay, I'm gonna add this one. The next feature is impact analysis. So impact analysis is really for the stage when you have a model, a calculation model, which is static. NPV calculation, cost calculation model, whatever model that does not have any stochastic elements in there. So what you do is, you know what the outputs are, right? The NPV model, what you're interested in is the final NPV calculation. So you know where the model, the output is. You go and mark the output, and then you need to think to yourself, okay, so how do I make it stochastic? So which cells do I need to mark as distributions, or to define distributions? So how do I do that? Maybe there are many of those cells candidates. And the good thing, of course, the correct thing would be to actually analyze the model and then see which inputs are affecting the output the most. And with this new tool, impact analysis, it allows it to do it automatically. I'm going to show you again live on screen. So a model currently without any ModelRisk functions in it. It's calculating something. So there are formulas here calculating the NPV, and NPV is here. So what I'm going to do now is I'm going to mark this cell as an output distribution. So this was an output. All right. And now I'm going to go to Model Impact Analysis, and I can add the cells that I think are feeding into the output, or the output is dependent on. But what I can also do is I can just scan the whole workbook and define those candidates. Okay, so I'll click that and go scan, and then it scans the whole workbook. It scans the precedents, predecessors, of that calculation. It ranks them according to whether they have names, whether they have how far in the predecessors chain they are, whether they are part of the, whether they have a range named range, etc., etc. So it scores them so that if there are thousands of them, you can actually focus on the top, say 100. Then you go add selected. Okay, they select. So the names are taken from nearby cells. So it actually does a smart lookup of the names of those variables, right? And then what you can do is you can just select and then start the analysis, and then see how each one of those, you can see that there are 5 that have a direct influence on the NPV, and the three variables at the bottom, they don't have a big impact, but the first 2, they do have a great impact on the NPV. So these are the candidates for you for making them into distribution. So, and from this specific interface, you can even define a distribution. So you can pick a distribution, assign it, and then the model will be ready for further Monte Carlo simulation. All right, and then we go next, 2 more to go. So the next one is another additional analysis called extreme scenario analysis. So this is for the scenario or the situation where you already have a model, a stochastic model built that you would like to stress test. You would like to see and analyze the extreme scenarios and see how those extreme scenarios will actually affect your bottom line or your calculation outputs. So what you do is, and I'm gonna load Excel. Okay, so there's a model. It has some inputs defined as the PERT, Poisson distributions, or whatever. You have some outputs here, reserve requirements, for example. And what I'm trying to do now is to see, okay, so if one of those inputs is stressed, in other words, if you sample from the distribution, but not from the whole distribution, not from, if it's like a PERT, not from 0.3 to 3, but sample, to 5, but sample from, say, the top 10 percentile. So if all of the values from these distributions are coming from the top 10 percentile, what would happen and how would that affect my NPV? So what I'm doing here, I'm gonna, again, under the model, I'm gonna go extreme scenario analysis. I'm gonna define my output. Output is here. And my inputs are, I'm gonna just grab my inputs here. So these are my inputs. I'm gonna select them and I'm gonna, okay, now I'm, okay, to all of them, I'm gonna just, for the simplicity of the demonstration, I'm gonna just say that I'm gonna choose the percentiles, say from the 90th to the 100th percentile. So each of those distributions will be sampled in the higher percentile value. And when I click Start Analysis, it will run 1, 2, 3, 4, 5 simulations, each time with as a new variable being run in this highest percentile is stressed, basically. So do that. Okay. Okay, and now I have my, say, a report, my box plot showing me the baseline case, and then the case, the 5 stressed scenarios. So how does my NPV change if that specific variable is stressed? So if I go back, I can even show that in the results viewer. I can just say, okay, so I'm gonna be comparing my baseline NPV against the NPV where my standard large loss severity is stressed, so it's at its high side, high tail. So if it's at its high tail, then NPV is going to be like that. Okay. And finally, the last feature that I would like to highlight is a GoalSeek functionality. It's there is a GoalSeek in Excel, but it's static GoalSeek. It's an optimization engine with just one variable. But what we've implemented in ModelRisk is a stochastic GoalSeek, allows you to do the same type of analysis, but with the stochastic model. So when the inputs are stochastic and the outputs are stochastic. So basically what will the inputs need, what the inputs will need to be in order for, say, the percentile or the chances of being above zero are 90%, for example, right? And it's a very, very simple interface. So let me find it. Yes, so we have an insurance premium, and we need to find the price at which we are going to be selling that insurance premium. We have this underwriting profit, which is our target. So we go here, again, GoalSeek, and the target is the profit. And the profit, we want it to be, say, the 10th percentile should be 0. So only in 10% of time we will be going below 0. In 90% of the times we'll be going, well, we will have a profit, basically. And the input is this. Okay, and we can set the limits, the bounds, but we're not gonna. So, and just click start, and it searches, and it finds that the premium is 66.9 or whatever. So it's our competitive offer that we can give to our customers, right? Okay, so that finishes the part about what's new in ModelRisk. Again, to wrap up, remind ourselves what it was. So highlight, impact analysis, extreme scenarios, and GoalSeek. And now it's what's coming, maybe more interesting for some of you. So on the roadmap, ModelRisk MCP is going to be released very soon. We already have it on our website. In GitHub, it's an open source tool for you who like working with AI, right? So AI, like Claude and others, they can automate a lot of things. And for them to be able to automate your Monte Carlo simulation models, this is exactly the tool you would need, who knows how to work with ModelRisk and who can tell the AI engine like Claude how it's done and provides you that bridge. So in Claude, you can go into the chat box and say, okay, so here's the model, open Excel, open the model, fit the distribution, run the Monte Carlo simulation, and then create me a report that shows me this and this. And with this specific bridge, Claude or other AI tool will be able to do all that without you needing to drive the whole process. So very useful tool, allows you to automate a lot of things when working with AI agents. Second thing is optimizer. We've already had optimizer before, years ago in ModelRisk, then we decided to remove it, but now we are bringing it back. It's going to be a fully functional multi-variable optimization. It's going to appear soon in ModelRisk. Stochastic optimizer. And finally, but not less important, we'll have a native engine for running Monte Carlo simulations. So some huge Monte Carlo simulations can be very slow, and this feature will allow you to simulate the same model, hundreds of thousand times faster. So we've tested on some of the models. They were running, say, 1 sample per second, because they were doing, fast Fourier transformations and lots of Excel calculations and sorting and stuff like that. And that's why the simulation was very slow. If when using this tool, we could do 1,000 iterations per second. So now the analysis is becoming much more, much faster, and you don't need to spend your time waiting for the simulation to finish. Of course, not all of the functionality will be supported to start with. It's going to support some limited functionality, but still, for most cases, it's going to be very useful. And it's a feature similar, if those are ones who remember that in Crystal Ball there was this thing called extreme speed. That's a similar thing. that we are developing, but it's going to be much more effective and efficient, right? And there are other features that I'm not listing here. It's like the facelift of ModelRisk and some wizards that we're working on that allow you to build models faster. So those ones will be showcasing later. Be with us, and we'll try to tell you what the new features are. Okay, so that that is. I hope you enjoyed my session. Now is your chance to help us a little bit shape the future developments, and we really appreciate if you participate in this poll, the next poll that my colleague is gonna be soon putting on screen. So, and the poll says.
Give me just 1 second, Timour. We had a couple of questions, so
okay.
I'm going to put the poll, but maybe you can answer them.
Sure.
One was, and I think that Aman already answered, was if this is going to have, this is going to be a separate product, ModelChoice. They were making reference to ModelChoice.
Yes, it's going to be a separate product. Yes, indeed. We are thinking of selling, our products in a bundle, but that offer is not yet formed. So, but maybe it's going to come soon.
Excellent. So the next question was, well, I think that you show it, right? It says, are continuous functions available in ModelChoice instead of point estimate? But I think that you already showed that you can integrate with ModelRisk, right?
Yes. That's correct. Of course, all of the inputs that feed into ModelChoice can be made stochastic. Yes.
Excellent. And there's another question. Thank you, Ben, for this. It's in the what is considered the best path in the ModelChoice. It's can you change it? For example, one time is time versus money versus least spend. So if you can change if it's going to be minimizing or maximizing the best path.
Oh yes, well definitely. I mean the mechanics of how it all works is very customizable. So you can minimize or maximize, etc. So there are options that allow you to choose how the tree is calculated, etc. So all that is available and also described in the manual.
Excellent. And we have one also about ModelChoice. It says when you calculating the expected value of the multi-criteria, right? Does ModelChoice use the arithmetic or the geometric mean? This is a very technical one, but maybe you have the answer on this one.
Well, it uses that specific one. Even I need to go and ask the developers, but it uses the utility theory basically for that. But maybe we can respond to that after the meeting.
Excellent. Thank you so much, Timour. So what I will do, I will put the poll there up for everybody, and I think that Aman, the floor is yours now. So it is coming in a second, but see, it's coming. Here you go. So I will launch it now.
Okay. Yeah, the poll is basically about your advice on what not even advice, but on what would be useful for you, the risk modeler, in terms of the new features and what's important. Basically, the faster simulations, the more confidence that the model is right, whether a clearer line from the numbers to the actual decision, getting the non-technical stakeholders to understand the risk, so presenting the results, and then AI, right? AI integration and use of modeling with AI. So if you can pick one thing that you think is most useful, that will really help us to define our future roadmap. Thank you very much. Okay, and with that, I'm going to pass over to my colleague Aman. Thank you very much, everyone, for attention.